Hello viewers, welcome to Fusion Mobile Mathematics Clinic. Today we'll be treating a topic called progression. What are progressions? Progression or sequence are the arrangement of numbers in a definite order. This order may be a constant difference, which we call arithmetic progression. If for instance, if we have 1, 3, 5, 7, 9, and so on and so forth. That is, there's a difference of 2. It's a constant increase and an addition. So this is called arithmetic progression. And the order also may be a constant ratio. Give for instance, we have 1, 2, 4, 8, 16, and so forth. This is an example of what we call a geometric progression. Also, we'll be looking at what we call series. Now, for series, it's simply the addition of a progression or a sequence. If, for instance, the example I gave, if we start adding all of them, that is 1 plus 3 plus 5 plus 7 plus 9 plus, and it goes like that. Right? So that is a series. Now, it's important to note that we have two forms of series. We have the finite series and also the infinite series. For the finite series has an end. That is, it goes from the beginning and it goes maybe like this one all the way to, let's say, 15. But an infinite series is that will go from the beginning and does not have an end. It goes to infinity. That is an infinite series. So first of all, let's look at the first form of progression we'll be looking at today, which is the arithmetic progression. In general, it is represented like this: A plus D, A plus 2D, A plus 3D, all the way to A plus N minus D. A is, which we call T1, is the first term. That is A. T2, which is the second term, A plus D. T3, third term, A plus 2D, and so on. But we have also the nth term, which is what? A nth term, which is A plus N minus 1D. You can notice that the third term, 3 minus 1 will give us 2. Second term, 2 minus 1 will give us 1. This has a 1, you consider 1. So that's the arithmetic progression. So whatever term you are looking for in the arithmetic progression, you use this formula, you get it. Now, let's look at the sum of the progression. That is the sum of the arithmetic, which we have established as a series. We can call it arithmetic series. For the sum, that is, we are adding each of the terms. The first term A plus the second term A plus D plus the third term A plus 2D plus the fourth term A plus 3D, all the way, adding all the way to the last term, which is A plus N minus 1D. Now, the formula for finding this sum, let's call it Sn, is equal to n all over 2 bracket A plus L. L representing the last term. Last. But we also have a second formula in case the last term is not given. is the same thing as n all over 2 bracket 2a plus n minus 1d. So these are the formulas that will help us to solve problems in arithmetic progression. Now let's take some examples to further explain arithmetic progression. The first question we have is, the third term of an arithmetic progression is minus 9 and the seventh term is minus 29. Find the 10th term of the progression. So for number 1, they gave us the third term. Remember that we said that for the general nth term, that is a plus n minus 1d. So for the third term, which they gave us as T3, it shows that this will be a. We don't have the first term, but we know that it will be 3 minus 1, which is what? 2d, equals to, they gave us the term as minus 9. Then for the seventh term, they gave us as 20 minus 29, but we have a plus 7 minus 1, following this formula, that will be 6d. Now, they told us to find the 10th term. For us to find the 10th term, we have to have the first term, which is a, and the common difference, which is d. Now, for us to do this, we have to solve simultaneously. So, solving simultaneously, we have a minus, we are going to minus to eliminate a. A minus a will be 0. Then 2d minus 6d will give us minus 4d. Then for this side, we have minus 9 minus minus. Minus and minus is plus. So we have minus 9 plus 29, which will give us what? 20. So d will be equals to 20 all over minus 4, which will give us minus 5. So d is equals to minus 5. Now, we now substitute in one of the equations. Substitute for d. Let's take it as the equation 1. Calling this equation 1 is equation 2. So we substitute equation 1. So this will give us a plus 2, where we see d, we put in minus 5. So that bracket minus 5 equals to minus 9. When you open it, that will be a minus, because plus 2 times minus 5 will give us minus 10. Then take minus 10 to the other side, so this a equals to minus 9 plus 10, this will give us 1. So a is equal to 1. For the 10th term, we know that 10th term will be a plus 10 minus 1, which is 9d. So wherever we see a, we put in 1 plus, what is 9? 9d is what? Minus 5. So this will be 1 plus 9 times minus 5 will give us minus 45, which will give us minus 44 as our answer for the 10th term. So that is how we solve the first question. Let's go over to the second question. For the second question, we have find the sum of the first 18 terms. So let's look at the terms. They gave us the series as 3, 6, 9, and so on to 36. Now, first of all, we know that A is our 3 here, because that's the first term. Now, for common difference, to find the common difference, we minus the first term from the second term, or the second term from the third term. That is how we find common difference. So, what is our first and second? We have first term as 3, second term as 6. So, it will be 6 minus 3, second term minus first term. That will give us what? 3. So our common difference is 3. Now, if you remember in the question, they said the first 18 terms, so n is equals to 18. Now, 36 here is not our last term. In fact, 36 here is our 12th term. Right? So this will not be our last term. So when we want to find the sum, we will not use the first formula, which is n over 2 bracket a plus l. We'll be using the second one, which is Sn equals to n all over 2 bracket 2a plus n minus 1 d, closing the bracket. N, which is number of the terms, is 18 all over 2. 2 times 2a is 2 times a is 3 plus n is what? 18 minus 1, and d is what? 3, closing the bracket. This will go here 9, so we have 9. This time this will be 6 plus this minus this is 17 times 3. This will give us 9 bracket 6 plus 3 times 17. 3 times 7 is 21. Carry 2. 3 times 1, 3 plus 2, 5. You add those two, that will be 9 times. When you add this, you have 57. So we multiply. 9 times 7 is 63. We put 3, carry 6. 9 times 5 is 45 plus 6 is 51. So this is the sum of the first 18 terms. I believe with these examples, we know how to solve questions in arithmetic progression. Now let's look at geometric progression. Geometric progression. In general, progression is represented by AR squared, AR cubed, all the way to AR n minus 1. So definitely, first term is equals to A. Second term, AR. Third term, AR squared, all the way to the nth term, AR n minus 1. Note that for the common ratio R, it is the second term divided by the first term, that is AR all over A, or the third term all over the second term, AR squared all over AR, and so on. Now let's look at the geometric series, that is the sum of a GP. Let me shorten it like that. The sum of a GP. That is, we are adding all the terms AR cubed plus all the way to AR n minus 1. Now, for us to add a geometric progression, we look at two conditions. The first condition, if R is greater than 1. So if R is greater than 1, our formula will look like this: A brackets R n minus 1 all over R minus 1. But if we have 1 greater than R, or R less than 1, whichever the case will be, excuse me, the formula will be equals to A bracket 1 minus R raised to power n all over 1 minus R. You will notice that for R greater than 1, R started on this side. That is, R raised to power n was the first here. But for 1 greater than R, 1 started came before the Rn. So that is also a pointer to be able to remember the formula. Also, we look at the sum to infinity, sum to infinity of a GP. Now the formula for this is equals to A all over 1 minus R, where A is the first term, R is the common ratio. So with these formulas, we'll be able to solve questions on geometric progression. Now let's look at some examples to further understand geometric progression. We have 3 questions on the board. The first one, the second term of a geometric series is 4, while the fourth term is 16. Find the sum of the first 5 terms. Now, for the first question, we are given the second term, T2. Second term, we write it as A R raised to power 2 minus 1, which is 1. So that is AR is equal to, they said it's 4. Then we are given fourth term, T3. 3, 4. It's such that it's A R raised to power 4 minus 1, which is 3, and it was given as 16. We have the second and the fourth term. Now, for us to find the sum of the first 5 terms, we need to find A and we need to find the common ratio. So, for us to do that, let's divide the 2 terms, that is term 4 divided by term 2. So this should be such that we have AR cubed all over AR equals to 16 all over 4. A cancel A, R cancel one of these to give you R squared equal to 4 goes in 16, goes there 4 times. So R will now be square root of 4, which is what? 2. Now we have our common ratio. For us to get A, we substitute for R in T2, that's the second term. So that will give us A, what is R? We have R as 2, so that will be A times 2 equals to 4. So A will now be equal to 4 divided by 2, which is equals to 2. So we have R as 2 and A as 2. Now the sum of the first 5 terms, so that means N will be equal to 5. Excuse me. We have R already as 2, A as also 2. From our common ratio, we already see that R is greater than 1. So we use the formula Sn equals to A bracket R raised to power n minus 1 all over R minus 1. So this will give us A, which is 2, bracket R, which is what? 2 raised to power n is 5 minus 1. Close the bracket all over 2, which is R minus 1. So this will give us 2 bracket 2 raised to power 5 is 32 minus 1 all over 2 minus 1 is 1. So this will give us 2 bracket 32 minus 1 is 31. So this is 2 times 31, which will give us what? 63, which is the sum of the first 5 terms. Now let's look at question 2. For question 2, it says find the sum to infinity of the following series. So let's look at it. We have the following series as 0.5 plus 0.05 plus 0.005 plus 0.0005 all the way to infinity. Now, we know that our formula for sum to infinity is equal to A all over 1 minus R. So we need A. Already we have A as equals to 0.5. But R, we know that to find R, we take the second term divided by the first term. So that will be 0.05 all over 0.5.
carry the point, so this is 0.5 all over 5. 5 will go here, 0.1. So R is equals to 0.1. So we come back to our formula, sum to infinity will now be equal to A, which is 0.5 all over 1 minus 0.1. This will give us 0.5 all over 1 minus 0.1 will give us 0.9. Then we carry the point. You carry these ones, carry the numerator ones, because whatever you do to the denominator, you do to the numerator. So this will give us 5 all over 9 as our answer for question number 2. Now let's look at question 3. It says, if the sum of the first two terms of a GP is 3 and the sum of the second and the third term is minus 6, find the sum of the first term and the common ratio. Let's look at it. We take it one after the other, the statements. The first statement says the sum of the first two terms. First two terms means the first term and the second term. So that will be first term plus second term equals to, they said, 3. So let's represent it. This will be A plus AR for the second term equal to 3. Factorizing A, that is bringing it out, that will be A bracket 1 plus R equals to 3. Equation 1. Now for the second statement it says, and the sum of the second and the third term is 3. So second term T2, third term T3, it said equals to minus 6. So T2 is represented as AR, T3 is, as the third term is represented as AR squared equals to minus 6. Factorizing, what is common? A is common, R is common. So we bring out AR. We now have 1 plus R left in there, also minus 6, T2. Now, we're told to find the sum of the first term and the common ratio. So we need to find A and R. So to do that, we take the first equation, equation 2 divided by equation 1. So the first equation, that will be AR bracket 1 plus R all over A bracket 1 plus R, then equals to minus 6 all over 3. So A will cancel this out. This one will cancel this out. What is left is R equals to, this will go here, minus 2. So our common ratio is minus 2. Now to get the first term. For the first term, we substitute. Let's substitute in equation 1. So let's say substitute for R in equation 1. So equation 1 is A bracket 1 plus R equals to 3. So R, we know R as minus 2. So where we see R, we put in minus 2. So that will be A bracket 1 plus, instead of R, minus 2. Close the bracket equals to 3. Open the bracket in here. So we have A bracket 1 plus times minus is minus 2 equals to 3. 1 minus 2 is minus 1 equals to 3. So A is equals to 3 all over minus 1, which is minus 3. Now, back to the question. The question said, find the sum of the first term and the common ratio. So, the sum will be A plus R. That's what we are told to find. And this will be A is minus 3 plus, what is R? R is minus 2. So, this will be minus 3 plus times minus is minus 2. And we have minus 5 as our answer. Now with these examples, I believe that we'll be able to solve questions in both AP and GP.